In this video, we're going to continue our work in section 17.1 on parameterized curves. So let's look at example 1. So the example 1 says, as in the preliminary example above, sketch and describe each parameterized curve below. So we're given in part A, x equals 4 cosine t and y equals negative 4 sine t, where t goes from 0 to 2 pi. So we're being a little bit sloppy in the notation here, but you'll see this in textbooks as well, to abbreviate parameterized curves by just giving x and y coordinates as functions of t. So we should say here, to be more formal, r of t, our curve, is equal to x of ti plus y of tj. But again, for brevity and just being more direct, we often see this coming to us as functions of t in the x and the y. All right, so to get started on graphing part A here, what I want to do is go ahead and set up a table like we saw in the preliminary example. So I'm going to have some various values of t. So we're going to let t be, say, 0, pi over 2, pi, and 3 pi over 2. So one comment here, my choice of what to put for t comes in from how my x and y look. So x and y here are given to us by sines and cosines, which have a period of 2 pi, and they have kind of significant or maybe interesting values at intervals of pi over 2. You can imagine a sine function looks like this-ish. And so we have the 0, pi over 2, pi. So we have like some big changes at pi over 2s. So that's why I choose to have these intervals of pi over 2 to determine what my curve looks like. Okay, so those are going to be our t values, and we're going to input them into our x and our y functions. So let's go ahead and fill in this table so we can see where the points land on our curve. All right, so first let's check out when t equals 0. So when t equals 0, we're going to look at x of 0 and y of 0. X of 0 will just be 4 cosine t. Y of 0 will be negative 4 sine of t. And rather not t, 0. I'm plugging in 0 now for t. All right, so 4 times cosine of 0, well, that's just going to be 4 because cosine of 0 is 1. Negative 4 times sine of 0 is just 0 because sine of 0 is 0. So that means when t is 0, x is going to be 4 and y will be 0. So let's do one more together. So how about when t equals pi over 2? So now we'll look at x of pi over 2 and y of pi over 2. So here for x, we're going to get 4 cosine of pi over 2, which cosine of pi over 2 is just 0. So we'll get 0 here for the x. Then we'll get negative 4 sine of pi over 2. Sine of pi over 2 is 1, so this just becomes negative 4 times 1, which is negative 4. So this point looks like 0, negative 4. All right, so what I'd like you to do is pause the video and finish filling in the table for the next two values of t. So when t is pi and when t is 3 pi over 2. All right, so when you're ready, I'm going to go through what those numbers look like. So for pi, we should be getting negative 4 and 0. And for 3 pi over 2, we should be getting 0 and 4. Okay, awesome. Not too bad. So let's go ahead and draw a picture of what this looks like here. So I'm going to draw first a set of axes. Great. So my points occur at 0s and 4s. So I'm going to mark along here. 1, 2, 3, 4, 1, 2, 3, 4. So my first point, 4, 0, is right here. And I have 0, negative 4. So now we're down here. So we could write r of 0, r of pi over 2. And then at pi, we are at negative 4, 0. R of pi, And then our final point is up here at 0 and 4, r of 3 pi over 2. So what it's looking like is that our curve here is a circle starting at the point 4, 0, moves around in a clockwise direction like this, and being centered at the origin. So a way to check this, to check that in fact our curve does look like this circle centered at the origin with a radius of 4, is to use that equation of a circle that we saw in the preliminary example to check. And we can also see here, just looking at the coordinates though, x and y are determined by cosine and sine. So you might recall that when we're drawing out a unit circle, the points on the unit circle are cosine and sine. And so it has very much this feel. The negative here, the consequence to that is just that we're tracing out the circle in our clockwise direction. And the consequence of the factor of 4 is just scaling out our unit circle to be a circle with radius 4. Awesome, great work. In the next video, we'll pick up on part B of this example.